Hi, kindergarten. Welcome to week 5. Let's go through your lessons for the week and what you guys are going to be doing. We are on a new chapter, so chapter 5. We're getting at the very end of our unit. So on day 1, we have helped the principals figure out why their playgrounds were different temperatures and why the students were uncomfortable at different times of the day. Okay, and you see Carver and Woodland playgrounds. Our investigation question that we're looking at is, when does weather affect people most? So sometimes weather becomes very strong. Weather scientists study what happens when weather becomes very strong and how that might affect people. We're going to read this book together. Okay, as we read, I want you to think about Lynn's observations and predictions, and then make some of your own predictions as well. This is called Tornado. Lynn Burse is a scientist who studies weather. Lynn knows about all different kinds of weather. She spends a lot of time thinking about severe weather, which is very strong or bad weather. Lynn loves her job. She says, "I like that the weather is different every day." She also likes that she can help people stay safe from severe weather. Lynn works with other scientists at the weather station. The scientists study the weather together. Lynn says, "It's great to be part of a team." A big part of Lynn's job is predicting the weather where she lives. She uses observations of the weather that is happening now to think about what will happen next. Many people use the predictions that Lynn makes. Farmers need to know what the weather will be like so they can decide when to plant their crops. Pilots need to know when and where it is safe to fly planes. All the people who live in Lynn's area need to know when severe weather is coming so they can prepare. To make predictions, Lynn uses many types of data. She checks how fast the wind is blowing. She checks how much rain has fallen from the sky. She checks the temperature. She also looks at how the weather is changing over time. The next page shows some of the tools that Lynn uses to measure the weather. So let's look at some of these tools. This tool measures how fast the wind is blowing. This is a thermometer. It measures the temperature. This tool gets energy from the sun to power all the tools. This measures how much rain has fallen. And this tool measures what way the wind is blowing. Different kinds of weather happens at different temperatures. When temperatures get warmer, where Lynn lives, thunderstorms can happen. Those thunderstorms sometimes lead to tornadoes. A tornado is air spinning from a cloud down to the ground. The wind in a tornado is very fast as a race car. A tornado is one type of severe weather. Tornadoes can be very dangerous. Their fast winds can lift big things into the air and damage buildings and trees. That's why it's so important for weather scientists to know how to predict tornadoes. Weather scientists warn people when a tornado is coming. Lynn says her biggest hope is that people will have plenty of time to prepare when she and her team send out a warning. One winter day, the weather was warm, wet, and windy. Thunderstorms were coming to town. Lynn and her team predicted that a tornado was forming. They had to warn people about the tornado. Lynn and her team sent warnings to all the people in the town. They wanted everyone to be able to prepare for the tornado. At the school, the principal told students to stay inside and away from windows in the strongest part of the building. When the tornado hit the school, all the students were safe inside. Luckily, no one was badly hurt, even though buildings, cars, and buses were damaged. Lynn and her team had predicted the tornado in time. They had warned the whole town, and people had time to prepare. The scientists had done a great job. Lynn says weather affects everyone, every day. Lynn says her job is interesting and rewarding because she helps people understand the weather around them. She likes using science to help people stay safe, even when the weather becomes severe. So, how did the strong weather that we read about affect people? Remember, it looked like the buildings were torn down, the buses were moved, it looked like there were a lot of damage, but it didn't hurt the people because they were able to be prepared. Part of Lynn's job is making predictions about the weather. Why do weather scientists predict weather? Why is her job to see what's happening and to warn people? Vocabulary: severe, strong, very strong, or harmful. On day 2, we're going to be looking at if weather is severe or not severe. So if I look at this picture, I see in this picture it's raining. She's holding an umbrella. Doesn't look like there's much water on the ground. I'd say that's not severe. But if I look at the picture to the right, there's a lot of water. The cars are having trouble getting through. I'd say that's pretty severe. That looks like a flood. In this picture, it looks very windy. However, it doesn't look like there is anything blowing over, and it doesn't look like the people are going to be harmed. So I'd say this is not severe. However, in this picture, it looks like it's blowing so hard that the trees are blowing in the wind, and it looks pretty hard. I'd say this wind is severe. I'm going to show you a couple more pictures, and remember, these are on your page as well, and I want you to decide, is this severe or is this not severe? In both of these pictures, there's flooding. Is this one severe? Is this one severe? In both of these pictures, it's snowing. Is one severe? Is one not severe? When does weather affect people most? Our key concept, weather affects people most when it is severe. So weather affects us at all times, but when it's severe, it affects us more. So we're going to do a couple of modified types of weather movement routine. So more and less severe wind, I want you to move your arms back and forth more strongly and less strongly, okay? So if you're moving your arms back and forth, if they're just going back pretty ease, right? That's not very severe. But if you're moving your arms back and forth, then that's more severe, right? Now, when you have more or less severe rain, you might wiggle your fingers. That's pretty not severe rain, but if you wiggle them a lot and it's a lot of rain, that's going to be severe weather. And then the same with more and less severe snow with the wiggling your fingers. On day 3, we're going to talk about the principals at Carver and Woodland. They're happy to see our work as weather scientists now that they have a new problem, okay, and they need our help again. So thank you for your work as weather scientists to help with the temperature problems at our school. Now we would like your help with a new playground problem. Carver and Woodland both have lots of rain during this time of the year. The problem is that Woodland's playground floods from all the rain and the students cannot go out to the playground at recess. Will you help us figure out why Woodland's playground floods? To help you, we've sent some new weather data from our schools. Sincerely, Miss Hood and Mr. Jenkins. So a flood is when a lot of water covers a surface that's usually dry. The Woodland playground floods after it rains, and the Carver playground does not. So here's the Woodland playground, and it seems to flood, but the Carver playground does not. Our Chapter 5 question is, why does only Woodland Elementary School's playground flood? So as weather scientists, we think about cause and effect. What is the weather that we are noticing? We can look at the weather data from each playground to see if differences in the types of weather on each playground might be causing the difference in flooding. Weather graphs are a good way to learn what the weather is like in a place. So this is the new weather data from Carver's playground. What do you notice about the types of weather? Here's what they recorded. I noticed that there's a lot of rainy days, right? It rains 12 days, and it was cloudy 2 days. And this is for Carver. I noticed the same exact weather. So it doesn't rain more at Woodland than it does Carver. It rains exactly the same. So each school had lots of rain during this time of the year. When there's a lot of rain falling at once, we can say that the schools are having severe rain. Severe rain can cause flooding. Woodland might be flooding because it has more rain than Carver. But when I look at these two graphs, I can tell that it rained the same in Woodland and Carver, right? It rained 12 days in Carver and 12 days in Woodland. So that has to be wrong. So does it rain more in Woodland than Carver? No, and my evidence is from these graphs. They took observations and they recorded their data, and now they know that it rains exactly the same. So I want you to look at your paper and I want you to find the differences between the two playgrounds. Okay, one difference I notice is that the garbage cans are different, or this one has a fountain and this one does not. See if you can find any more differences. On day 4, why does severe rain flood some places but not others? So how could we investigate which of these differences cause Woodland's playground flooding problem? What could we do? What makes it hard to investigate these differences in the real world? Can we go to Woodland and Carver and make it rain on their playground? Not really. So we have ideas about which of the differences cause flooding, right? As weather scientists, we have to test each of the differences to see if it could cause flooding. Let's look at the models and see if we can use them. So we can use this model to test whether the trash can covers can cause the playground to flood. Do you see how the cup has trash cans? We're going to call those trash cans, but one has a cover and the other does not. We can use this model to test whether the fountain can cause the playground to flood. So this cup has a fountain, right? But this one does not. So we're also going to use this model to test whether the color of the surface can cause flooding. So this cup has a white bottom and this has a black bottom. We're going to see if that makes a difference. And then this cup has gravel and this one has clay. We're going to see if the surface can cause the playground to flood. Okay, remember that these models are just models. They're not the real thing, okay? And sometimes we use models just to make sure we can test things that are a little bit difficult to test in the real world. So we're gonna test what happens when it rains by sprinkling the same amount of water over each one. And you're gonna record your observations on your paper. So you guys have pages that look similar to this, but not exactly. It shows the real playgrounds and then the models. Okay, you're going to compare your models to the real thing. Just think about how they're different and how they're the same. And I want you to circle the cup that you predict will have a higher water level after you sprinkle water over both the cups. Or you can circle both if you think they're going to be the same. So I want you to watch and see how we're going to make it rain.
Let's look at how to create rain in the model. Place the rain cup over an empty cup to catch the rain. Pour water into the rain cup and gently shake it to create rain in the empty cup. Repeat this process with your other model cup with the same amount of water, so each cup gets the same amount of rain. With your partner, take turns creating rain in each of your cups.
Awesome. Oh, I want to move on. Okay, so for this, I don't expect you to do this at home, okay? So I'm going to do this for you. I'm going to record myself using these models and making it rain over the cups, and you're going to be able to record what happens, okay? I'm going to record that in a separate video and put that on YouTube as well, so you can watch that next. So I'm going to pour the water into the rain cups and sprinkle them onto the models, okay? And as I do that, you're going to be able to make your observations on your pages, okay? You're going to draw a line across the cup on the notebook to show where the water level is, okay? Just like this. So you're going to draw your lines. If it goes up to here, you draw your line right here. So after you get done, you're going to see if your predictions match what actually happened, okay? Once you observe, you're going to look and see if your predictions were right. Now, on day 5, you're going to decide how you have worked as a scientist this week, okay? Remember, scientists do different things to answer questions. Have we made observations? Did you watch me do something and you observed? Did you record what you saw? Have you read a book? Did we make models, or did I show you models? Did we compare models? And did we communicate with people? Today we figured out that there are 4 differences between the playgrounds, and we used models to test whether each difference could affect flooding. Next time, we're going to look at all the data from our models and discuss which differences could have caused the flooding. You can revisit your weather type movements. If it's sunny, you might wiggle your arms over your head. Okay, if it's cloudy, you might make circles with your hands around your shoulders like this. Okay, if it's windy, you might move your hands back and forth. And if it's raining or snowing, you might use your fingers like this. And that's the end of our lesson. Again, I'm going to do the rain model in a separate video, okay? On that day, you need to watch that video as well. Bye, guys. See you next week.